Hello, everybody. This is Stephen Whitfield, the drilling contractor. Happy to be with you from the 2024 IADC Advanced Rig Technology Conference in Austin, Texas. And with me right now is a guy who just spoke as part of a spirited session here at the conference, Mike Weidenfeller, Product Strategy Manager at Caterpillar Oil and Gas. We're going to be talking a little bit about sort of different fuel sources that we can use on our engines at the rig site, and also talking about sort of GHG emissions accounting and all that kind of fun stuff that's cool in the industry right now. So Mike, thank you so much for joining me today.
It's been my pleasure. IADC always hosts great events.
Well, and you were part of a pretty fun session here, so we'll talk a little bit about some of the things that you brought up there on the stage. So one of the things you mentioned, obviously Caterpillar Oil and Gas, you're talking about engines, and you brought up sort of a lot of the different sort of fuel sources that we can see. I mean, and there's a plethora that we're using now. And you sort of brought up the advantages and disadvantages of all these different fuel sources. And maybe we can't go over every single one that you listed, but can you sort of talk about sort of the main ones that we typically see out there, and what are some of the advantages and disadvantages that we have with using engines powered by some of these fuel sources?
Yeah, so I'd say the most commonly talked about ones are diesel, gas, and then hydrogen. It's a big buzz one these days. And some of those KPIs or key performance indicators that you might look for fuel sources, what's the price per energy? How densely can you store the energy? So like energy per unit volume. What's the density of the energy power? And so like what's its response rate? And then the landed cost of getting it to site. And so diesel has been by far the standard for the past several decades of, it's got its price per energy ratio, its energy density, and its low volatility have made it great for drilling in these remote applications. As people start caring more and more about GHGs or CO2e or CO2 equivalent, we're looking for, okay, that needs to become a KPI that we look at as well. And on a rare occasion, the government has helped made it a little bit simpler than looking at all the different types of calculation methods. The government's built it down to, if you look at your amount of fuel consumed times multipliers, and you can look them up on published tables, you can calculate your GHG. So as an E&P or a driller, you can simply look at, okay, at the end of the month, what was my fuel bill? And so gas is normally communicated in MMBTU. If we were to convert that to DGE or diesel gallon equivalent, diesel's about 10.2 per gallon. That's kilograms CO2e, and gas is about 7.3, and hydrogen, of course, would be 0. And so you're getting about a 30% GHG reduction by switching to natural gas. And it's a great thing for industry because it's also cheaper per unit energy. And when do your GHG reductions and your OPEX reductions align? One of the fallbacks of gas, though, is it typically has a lower transient response than diesel. And things that we're starting to see pop up more and more commonly, and actually we just released a new generation, is dual fuel. We call it DGB, or dynamic gas blending. And so I like to say the have your cake and eat it too product. It's a whole lot cheaper to upgrade an existing diesel engine to dual fuel than to buy a whole new engine. And so the dual fuel is getting 60%, 70% displacement, so like a lot of cost reductions, especially if you're getting access to well gas. And then it's also the have your cake and eat it too. Like what if you're doing an operation that really needs high transient, like you're tripping, you're pulling 10,000 feet of steel as fast as you can? All right, lower displacement, let's go diesel. This is where I'm willing to pay for performance. Or you're out in the middle of nowhere, there's no gas supply chain. You can revert back to the old reliable diesel that is energy dense, low volatile, and can be shipped anywhere in the world.
So you kind of mentioned the dual fuel sort of system. You talk about sort of hybridization and how you get the best of both worlds. And you kind of mentioned this already, but can you speak to a little bit more about the ability to sort of get the best of different types of fuel types when you're using sort of either a dual fuel or some kind of hybrid solution?
So in hybrid, a lot of people think of hybrid as a battery plus a fuel source, and that's really kind of been set by our automotive industry, our friends over there. It's hard to fight against that kind of marketing that they got going on. But to me, hybrid is really any rig that can use multiple fuel sources, whether it be diesel, natural gas, or even secondary like a battery or a grid, to leverage the pros and mitigate your cons because then his rigs move between different operations. Hey, I'm in a high transient, I want my high response fuels. Or I'm in a steady state operation, I'm just steady drilling, like I want my low cost fuels that don't need that transient response, let me switch to gas. Or I'm next to a utility line and I can power from the grid, get that high response, get that low cost. Or I'm out in the middle of nowhere, let me switch to these fuels in the engines. And so a rig that can change what fuels it uses based on not just operations but locations, those are going to be the most efficient, productive rigs of tomorrow.
So your presentation also really focused on GHG emissions accounting, and that's something, in this industry now we're hearing just so much about that now. So let's talk about the connection between emissions accounting and choosing the optimal fuel source. What do you think that emissions accounting can sort of help inform us about when we're looking at sort of the best fuel source to use in a given application?
I am really starting to appreciate the term accounting and emissions accounting more and more, that these are really like best practices or best standards. And so if you look at how people are calculating these days, the EPA issues these multipliers, and so as you have a company, it's like, oh, if I could pay an engineer to go figure out all the math and maybe what the actuals were, it'll be more precise, but there apparently is an acceptable level. It's like, why even take on the risk? I compare it to a standard tax deduction versus an itemized. Like, not only is it going to take more effort, but you're going to increase your risk getting audited. And so one of those few cases where the government made things simpler and easier. So if you look at that standard practice of looking at fuel consumption times your multiplier, then you, as an operator or a driller, okay, those are the two levers. And is what engineers are telling me to mitigate or reduce my GHG, am I affecting one of those levers? Am I changing one of my fuel sources to change my constant, like from diesel to gas to hydrogen? Or am I doing something to reduce my total fuel consumption while delivering the same value? Like, are you doing on-engine control management? Are you doing a blend of things so that I can switch between fuels for different operations? But that's why I kept focusing on that one slide that had fuel consumption times your variable. Are you doing anything to affect the value of one of those two variables?
Whenever we see equations, that's always going to be something particularly fascinating. So thank you again for not only your presentation, but for taking the time here to tell our audience about all this really cool stuff. So thanks again.
Oh, it's been my pleasure.
And thank you for visiting Drilling Contractor.